So thankfully, I tell you what, that my Monday, Wednesday 1325, it's been rough only because we have Monday the 1st off, and then we have Monday the 8th off. So we're missing 2 full days that you guys aren't missing. So I'm going to try really hard to not push you guys through too fast, because we have all of our days. Yesterday in class, I had to really push to get through the material. And I think that's why it got so overwhelming for them. So hopefully today you guys won't feel too overwhelmed. So I just sent out an email just to remind you that, because Monday's a holiday, you don't have anything due Monday night. So your homework won't be due until Tuesday night at before 11:59. So make sure that you kind of, adjust your schedule, or just pretend like it's all due Monday. And so if you've been getting it done before Monday, just keep doing it and get it done. So like I said on Tuesday, we really are winding up one last section in chapter 11. So what I would suggest to you is, since your test is coming up, and we have a date. So our third test is going to be Thursday, April 11th. So that's not that far away. It's going to come very quickly. So go ahead and start kind of reviewing your chapter 11 is the review. So in your modules, if you go to module 3, there is, where is it? There is a review. Here's test number 3 review. So you can kind of look at that. The solutions are there. You can kind of start working on it and working, I would say every day or every other day, just start doing a couple problems and see how that prepares you better for the test, for the upcoming test. Then the other thing, before I forget, is remember we talked about at the very beginning of the semester that a lot of times in math, sometimes when you see it for the first time and you get tested on it, it is a little bit overwhelming. You don't quite have the concept of it, and so you don't do well on the first test. And it's usually the first test. Usually by the second test, students have kind of figured out what I'm looking for, what it looks like, what kind of questions am I going to ask, that kind of thing, and just getting kind of the feel of the class. And so what I like to do is I like to allow you to go back and kind of redo one of the tests. And so what I'll do is, and I call it a test supplement. So what I do is, since we've taken 2 tests, you have a choice, right? Either or. You can't do both. It's got to be either test 1 redo or test 2 redo. And I average the 2 grades. So in your module 3, this is module 3, at the very bottom is test supplement 1 and test supplement 2. And then this is where you're going to submit your work. Just like you do with the test, you just submit your work. So this is going to be open on Sunday, March 31st. So this coming Sunday, it's open. It opens at 6 in the morning. And then you have the whole week, and it closes Sunday, April 7th. So it's a one and done. So it's not timed, but you only get 1 attempt. So if you open it and try to leave and come back, it's gonna close you out. You won't be able to finish it. So just pick a time that you can just sit down, do the test. I believe there's 10 questions on test 2 and 12 questions on test 1. And what I'll do is I will average your 2 grades. So for instance, if you got a 60 on test 1 and then you do the supplement and you get a 90, I average the 2, that 60 now becomes a 75. So it's a way to kind of boost your overall grade. in a way that you can go back and go, you know what, I did learn this material. I do know how to do the power rule now. And so then you're able to do much better on a test that maybe you didn't do so well the first time around. And the other reason why I do this is because April 12th is the last day to withdraw and get a W. So I want to make sure that you have an opportunity to improve your grade, especially for those of you who are like right on the edge. If you're in the 60s right now, that's going to be a real hard sell to do really, really well on the final, because the final's cumulative. And so it's difficult to do well on the final and bring that grade up. So I want to give you an opportunity to improve your grade without just giving you a grade. So I'm not going to replace the grade, but I'm going to average the grade. So any questions on that? It's all in MyMathLab. So
What if we do worse?
I'm sorry. Oh, if you can't ruin your grade. So it will only improve your grade. If you don't do well on it, I don't change the grade.
Okay.
But if you do well, then I will improve your grade.
Yes, ma'am. Yes, ma'am.
Okay. Yeah, I don't want to ruin your grade. I don't want to set you in a spiral that in the back or going in the opposite direction. I always want to move up. So okay, so that's available to you Sunday. And I'll send out a couple reminders to remind you throughout the week that don't forget if you want to. And so this is optional. If you are like, you know what, I like my test grades and I don't want to, spend the time doing this, then it's completely optional. It is not required. These will go away once April 7th is passed. The test supplements will go away because I'm just going to take the grade and average it and replace your whichever test you do. Okay, and then make sure you submit your work just like on all the other tests. You'll submit your work. Okay. Any comments, questions? Okay, if you aren't sure whether you should drop or not, talk to me before you drop, just to make sure, because I have seen students be able to pull themselves out of the D range, but you'll have to work for it. You definitely have to. I don't just give you the grade. You definitely have to work for it. So, okay, so we can move on. So, what we're going to do is we're going to finish up part 1 of the optimization. So again, we're in the very last section of our chapter 11. And so chapter 11 is, 11.1 was first derivatives and their graphs. That was with the test charts and all of that. 11.2 was second derivative, looking for concavity. How is the graph curving? Where does it curve? And then the 11.5 was absolute max, absolute min. So I wanted to take a look at that one more time because I know we only did a couple problems. And our absolute max and our absolute min will take us back to the idea that your maximum value, right here, the maximum value always happens at the highest point, and the minimum always happens at the lowest point. And the only place that maximum or minimum can occur is at the critical points or at the endpoints. Okay, so when we're doing our optimization, those are going to be the two key things that you're going to find is your critical points and your endpoints. If you can't find the critical points or you can't find the endpoints, optimization is going to really kick your rear. But if you understand the concept behind those two, then the optimization problems really aren't too bad, because this absolute max, absolute min, this is the last few steps that we do in our optimization problems. So our key is always finding the endpoints and the critical points. Okay, so we started this one on Tuesday, so I wanted to go ahead and finish it. So remember, we have our steps, but again, the steps are just helping us to guide us kind of through the process to remember, all right, what should I do next? But these should become, excuse me, these should become seamless, right? You should be able to just kind of smoothly go through the whole process. So the first part is when you can graph it. Or I'm sorry, draw a picture, not graph, draw a picture of it, because this helps us visualize what's going on. Okay, we always want to look at it and go, all right, what exactly is going on? So in this case, we have a homeowner. He has $320 to spend. That's his limit. That's as high as he can go. And he's trying to build a fence around a rectangular garden. 3 sides of the fence will be constructed with wire, which only costs $2 per foot. And then the 4th side is going to be constructed with wood that costs $6 a foot. So what we did is we set it up as the $6 side. We wanted to do it on the shorter side because it just makes sense. It makes better business sense. We're spending less money on the shorter side. The other 3 sides are going to be the wire or the cheaper material. So if I'm spending $6 per foot, that's, that's $6 times the width. And then if I'm spending $2 per foot for the wire, I'm spending 2 times my length, 2 times my width, and 2 times my length. Okay, so this is how we set this up. So this is, because these are dollar amounts, now these values are our cost. So it costs me $6 per foot in width. It costs me $2 per foot in length, and then $2 per foot in width over here. So then what we did is we said, okay, what's our objective? Our objective is the largest possible garden. So here's our objective right here. A equals L times W, which is just your formula for area of a rectangle. And now we get to our constraint, right? The constraint is what holds us back. Well, in this case, what holds us back is our money, right? We only have so much money to spend, and we're going to spend it in this very particular way. So we have 2L, so that's this one, plus 6W, plus 2L, plus 2W. So all I'm going to do is just add my like terms. So I have 2L plus 2L is 4L, 6W plus 2W is 8W, and all of this cost has to be less than $320. Okay, so this is our constraint. This is what's going to hold us back in this particular scenario. So then, like always, we always want to solve for one variable. So we just solved for L. So we got to this point. So once you get here, once you get your constraints solved for one particular variable, then what you're going to do is we are going to find our endpoints. Okay, so remember, endpoints is important because that's going to give us where our maximum or min, that's the an opportunity to find the maximum or the min or the minimum point. Okay, so I'm going to take my 80 minus 2W is greater than or equal to 0. So again, this inequality is different than this inequality, and it's on purpose. This is saying we have $320 maximum that we can spend. This, finding the endpoints, is saying I only want to deal with positive values. So it's actually talking about 2 different things. And so don't connect the 2. They're not connected. They're 2 completely different questions that we're answering. The constraint has to stay less than 320, but my endpoints is my domain. It's what can my width be? So and I'm going to solve. So I get negative 2W greater than or equal to negative 80. Divide by negative 2. Once I divide by a negative, it flips that sign. So my endpoints are always going to be 0 to whatever this value is, to 40. So that's as high as my width can go. I can only go up to 40 feet in my width. All right, so I've got my endpoints. The first thing is done. Now I have to find my critical points. And that's where we go into, I'm going to start over here. That's where we go into what I call step 5, right? And step 5 is we're going to plug the constraint into my objective function. So I take out, excuse me, I take out my length and I plug in what length is represented. Length equals 80 minus 2w. So I'm going to plug this right into here, into my objective function. So now I have a function all based on w. And so I'm going to distribute this through. So I get 80 times w is 80w. Negative 2w times w is negative 2w squared. And then just because I'm a stickler for it, it helps me, I rewrite it in descending order. Okay, so now think about this. I have an objective function with my constraint embedded in it. So this is the objective of a very specific situation. Very specific situation. I have only a certain amount of money, and I have a very specific amount of wire and a specific amount of wood that I'm going to use for my fencing. Okay, so it's an objective function with the constraint already embedded. So this is what I call my original function. This is what we're going to plug everything back into. Okay, so from this point on, it's just finding absolute max, absolute min, just like 11.5. So we're going to find our critical points. And we do that by finding the derivative using our power rule. We set our derivative to 0. And we solve for w. W equals, I'm getting too close. W equals 20. Okay, so I subtract 80. I get negative 4w equals negative 80. So my w equals 20. Okay, this is my critical point. So now I am good to go. I have found my endpoints and I have found my critical points. So now all I have to do is just evaluate. So I'm going to evaluate my area at 0. I'm going to evaluate my area at 20, and I'm going to evaluate my area at 40. And like we have found out, very often, we're plugging this back into our original function. So if I have 0 width, I have 0 area. Makes sense, right? It's all closed down. There is no area. If I have 20 width, I'm going to plug that in and calculate. So 20 squared is 400 times negative 2 is negative 800. And 80 times 20 is 1600. Is that right? So my total square footage is 800 square feet. Okay, and then with the 40, I'm going to plug that in, and you'll see very quickly that we end up with 0 again. So 400 or 40 squared is 1600 times negative 2 is negative 3200. 80 times 40 is 3200, so I end up with 0. Okay, so here is my maximum. Okay, all we know is that W equals 20. All right, I want to know what's my length. So where I'm going to find that is right here. That's why I circle my constraint, because it's already set up for me. L equals 80 minus 20. So 80 minus 2 times 20. So 80 minus 40 is 40. So my dimensions, length is 40 feet, width is 20 feet. My maximum area is 800 feet squared. And if I multiply these two, 40 times 20 does give me 800 feet squared. So you can see the calculations really do work. And that's a really quick way to double check that your answer makes sense. Okay, so in these, your answer should always, always, always make sense. Okay, so any questions? So the difference between this one and the one we did before, this one is based on how much money I am limited to. This one was based on how much area or how much perimeter and fencing that I have. So each one of them can be slightly different, but the process is always the same. And that's why I like to draw a picture, because like on this one, the one we did on Tuesday, remember it said that we have a rectangular parking lot, but the building is going to be on one of the sides. So to maximize my fencing, I'm going to take away the length, take one of the lengths away and make that the building, as opposed to making the width the building. So you always want to logically think it through and go, okay, as a business person, what makes the most logical sense? Okay, but again, the process is the same. You draw a picture, you get your objective, you get your constraint, you find your endpoints, which are right here. I didn't write it. And then you plug the constraint into the objective and then walk out the absolute max, absolute min. Okay. And then always the last step is you're going to find out what the other variable is. So in this case, we found our width, then we had to go back and find our length. And so you'll do that with every single one of these. You'll find one of the values and then you go back and you have to find the other value. And the way you find that is always right here. It's always going to be, that's why you always solve one for one variable. Okay. Questions? Am I going too fast? All right, I guess not. Okay. All right. So with these last two, what we're going to do is now we're going to transition into maximum revenue and then maximum profit. Okay. So this is where those steps can really trip you up if you try to focus on the steps. What I want you to focus on is I want you to focus on the endpoint, right? How do you find the endpoints? And the critical points. Once you get those two, then you can find your maximum. So how do you find endpoints? You find endpoints by setting the constraint to greater than or equal to 0, because you are looking for positive values. How do you find critical points? You set your derivative to 0 and solve. Okay, so really focus on those two things. If you put all of your effort into those two things, everything else will kind of fall into place for you. Okay, all right, so here we go. Office Supply Company sells X permanent markers. So X represents the number of markers per year at P dollars per marker. The price equation for these markers is P equals 10 minus 0.001X. What price should the company charge for the markers to maximize revenue? So there is our key term, maximize revenue. And then what is the maximum revenue? Okay, so here's our scenario. We have a company, we're selling permanent markers. This is our price. okay? X represents the number of markers, P represents the dollars per marker, and we're trying to maximize revenue. So before with the area, we came up with the area function. Now we have to come up with the revenue function. So with revenue and profit, you can't really draw a picture, but we can, so I'm going to skip the picture, we can find our revenue. So our objective is the revenue. How do you find revenue? Well, think about business, right? Revenue is all the money that comes in. Okay, so if I'm selling a product, let's say I'm selling t-shirts, right? And I have 100 t-shirts and I'm selling my t-shirts for $25 each. I'm very proud of these t-shirts, right? 100 number of products times the price, 25, that gives me my revenue of 2,500. Okay, so revenue is always the number of products times the price, every time. Number of products times the price. So number times price. All right, well, they have the price right here. This is my price. So to find revenue, I'm going to do the number of products, which is X is the number of markers, times my price. So my revenue in terms of the number of products is 10x minus 0.001x squared, and then I'm going to rewrite it. Just putting it in descending order. Okay, this is my objective. Okay, that's my objective function. What is the constraint? So what holds me back is my price. So with revenue and profit, your price is always what's going to hold you back, because you cannot overcharge, because if you overcharge, people aren't going to buy your product. You can't undercharge, because if you undercharge, you're going to lose money. Okay, so the price really does dictate what your business is going to do. So that's your constraint. That's what limits you. So if you notice, the price is already solved. So remember when we were walking through these before, we got our constraint and then we had to solve for one variable. Well, this one, it's already done. So that's why I don't want you to get caught up in, step 1, step 2, step 3. Get caught up in, okay, I have my constraint. It's already solved. I'm good to go. All right. How do we find our endpoints? We set our constraint to greater than or equal to 0, which makes sense, right? You want your price to be a positive value. If you charge negative $10, you're going to be paying people to take your product. Now you've lost a whole bunch of money. Okay, so now we're just going to subtract 10, divide by negative 0.001, and we get X is less than or equal to, that's a negative, 10,000. Okay. So my endpoint, so remember that's a goal. That's what we're looking for. We have an endpoint of 0 up to 10,000. And what are we looking at? Is that the price? Nope. Remember, X is the number of products. Okay, so the number of products, we can only make 10,000 products, whether that's because we don't have enough time in a day, maybe our material is only is limited to only 10,000, maybe our machine, can only do 10,000 in a day, or per year, per year. Okay, so we've gotten through the hard part. All of this was the hard part. This is the new stuff. Finding the objective, finding the constraint, finding the endpoints. Okay, this all is new to you, right? It's the same thing that we did before, but as far as a new concept, that's a new concept. But here's the good news when we're doing revenue and profit. See this right here, this function right here, this revenue function. This is our objective. it's already plugged into our, I'm sorry, this is our constraint, sorry. This is our constraint. It's already plugged into our objective. So this is our original function. This is our number 5. We already did it. You don't have to do it again. It's already done for you. Okay, this is our revenue objective function. This is our looking for the maximum revenue with the objective already, or with the constraint already embedded. Okay, so from here on out, it's just finding the derivative. Now we're looking for critical points. So we're going to find the derivative. 2 times negative 0.001 is negative 0.002 x plus 10. We're going to set that to 0 because why do we set our derivative to 0? Because that is where, remember what happens? That's where our slope goes to 0. That's where it flattens out. And that's where our maximum happens. Okay, so remember, this is why you do this, because you're finding the derivative. Derivative is slope. We're looking, where does the slope go to 0? That's what this means. That's what this part means. Where does the slope go to 0? Where does it hit its maximum? Okay, so now we solve. Divide both sides by 0.002. And we get x equals, so negative 10 divided by negative 0.002 is 5,000. And if you notice, always notice, we just found our critical point. Make sure your critical point fits within the endpoints. So we found our critical point of x equals 5,000. Okay, so those are our 2 focus points. We want to find our endpoints and we want to find our critical points. Okay. And from there, now we just evaluate. Enough room here. Now we're going to evaluate. So we are finding our revenue at 0. We're finding our revenue at 5,000. And we're finding our revenue at 10,000. Now, this is where it gets a little bit different. With area, when we plug in 0, we get 0 out. And that is going to be true for this one, which makes sense. Okay, there's our original function. If I plug in 0 products, I'm going to have 0 revenue. Makes sense. When I plug in 5,000 products, I get negative 0.001 times 5,000 squared plus 10 times 5,000. Did I write that right? Yeah. Okay. I'm going to rewrite my function here just so I can see it. Okay. So when I multiply all this out and add, I get negative 0.001 times 5,000 squared plus 10 times 5,000. So this ends up being 25,000. So that is money, right? That's all the money that comes in. If I plug in 10,000, I'm going to get negative 0.001 times 10,000 squared plus 10 times 10,000. And I believe this is 0 also. It's the profit one that comes back with values there. Yeah, so this ends up being 0 also. Okay, so remember, your answers need to logically make sense. So why would producing 10,000 products give me 0 revenue? How does that make sense? Anyone have an idea of that? I know it's Thursday. You got to talk to me, you guys. Any ideas?
Cost of material,
Yeah, that's
the cost to
exactly
make it.
it. Yeah, you're putting out way too much money. Okay, and so that's again, and I know I've said it before, but so often people who start a business, they think more is better. It's always better to start out small and then build your company up. Don't just jump all in and then expect to make a bunch of money, because you're going to put out a whole bunch of money when you first start out. So you want to make sure that you can recoup your costs. And so if you do more, that doesn't necessarily mean better. It just means more. And a lot of times you end up losing money for it. Okay, so we found our number of products. That's our X. Okay, and if you aren't sure what your variable or what your number represents, go back to what you solved for. So our critical point, we solved for X. So X equals 5,000. So we know the 5,000 represents the number of markers. Now we need to find out, okay, we know 5,000 markers is going to give us maximum revenue, but what is, remember, we always have to go back to what is our price? That's our constraint right here. What's our price? Okay, so we have to plug the 5,000 into our price function. And we get P equals 10 minus 5. So our price is $5. Now, I know this is a very expensive permanent marker, okay? But the idea is once you get your maximum profit, this is our maximum profit, or I'm sorry, maximum revenue, sorry, not to profit yet. Maximum revenue, this is the price. So this is where you guys are going to get to do your extra credit on this test. You're going to interpret this. Okay, so the interpretation is selling 5,000 markers at $5 each brings in $25,000 revenue. Okay, so that's how you would interpret that. $25,000 in revenue, 5,000 markers at $5 each. And look, because revenue is number of markers times price, number of markers was 5,000 times the price of 5 gives you $25,000. So again, your numbers should all make sense. If you ever get like 2 answers and you go, all right, when I multiply these, it doesn't come up to the right answer, there should be a valid reason for it. One, maybe you missed a negative, or maybe you wrote the problem down wrong, or maybe you added instead of subtracted, whatever the case may be. Always double check that your answer makes sense. It's just a way to really focus in on what do your answers mean. Okay, so any questions on this one? Okay, all right, so this last one that we're going to do is, now we're doing the exact same idea, right? We're going to look through it and see what we're looking for. So now we're looking at we're looking for maximum profit, and what is the maximum profit? So find the price and the quantity. Okay, so we're looking for same idea. The quantity is X, and the price is in dollars. And so the X represents the number of bikes. Okay, so again, can't draw a picture necessarily. What are we looking for? Our objective is max profit. Okay, how do you get profit? Profit is your revenue minus your cost. Profit is revenue minus your cost. So whenever you're looking for your objective function, always identify, all right, what do I need for my objective function? Do I have those things? So with this one, excuse me, we have to come up with it, okay? We have to come up with our revenue, we have to come up with our cost so that we can find our profit. So ABC Bikes finds that it costs $200 to produce each racing bike, plus the fixed cost of $1,500 a day. The price is 600 minus 5x, and then P is in dollars and X is the number of bikes. So we're looking for the price and the quantity to get maximum profit. So we need to find our cost function. So remember, cost is fixed plus variable. Okay, so fixed cost is 1,500. So we got our 1,500 already. And our cost per bike is 200. So plus 200 per bike. There's your cost function. Okay, and then we already know what revenue is. Revenue is the number of products times the price. They gave us the price. So our revenue is the number of products times our price. Okay, so where are we? Right here, right here. I'm trying to color code it for you. Okay, so our revenue, I'm going to go ahead and distribute, and I'm going to go ahead and flip it around. So X times 600 is 600X, X times negative 5X is negative 5X squared. And then I just wrote it in descending order. Okay, so with this type of problem, because we're looking at profit, we have to set that profit function up. We have to do the work first. So to get our objective, so remember, we're still working on the objective. To get our objective, we're going to take our revenue and we're going to subtract off our cost. So our profit is our revenue minus our cost. Okay, so we're going to clean this all up. Negative 5x squared. The negative goes through both of these. So I have 600x minus 200x is 400x. And then minus 1,500. Okay, now here's the good news. We did all the work. This is my objective function with my constraint already embedded. Because remember, the constraint is our price. Constraint will always be the price. So this is also number 5. This is also our original function. Okay, so we're good there. We're ready to go and find absolute max, absolute min. All right. Here we need to find our endpoints. Okay, so our endpoints means we want positive value of product. So our number of products has to be less than or equal to, 120. 600 divided by 5. 120. Okay, so we have our endpoints. So what's nice about this one is once you get through setting up your profit function, you've done 90% of the work, right? We found our endpoints. Now all we have to do is find our critical points. So our critical points, we find our derivative, set our derivative to 0. And divide by negative 10. So our critical point is 40. Okay, so we have our endpoints and we have our critical point. So we're good to go. We can evaluate. And remember, we're not looking for revenue anymore. We're looking for profit. We're looking for maximum profit. So we're going to evaluate the profit function at 0. So remember, when I plug 0 in here and 0 in here, those close out to 0. So I end up with a negative 1,500. So this is where you don't want to always just assume that when you plug 0 in, you get 0 out. Okay. And it does have, there is a very valid reason why it's negative 1,500. Right. So do you remember? That's why I did it in a weird color. 1,500 was our fixed cost. Remember, in business, fixed cost is money that gets put out like a startup cost. You don't sell anything, you don't bring any money in, it costs you $1,500 just to start your business. Okay, so it could be every year you have to put out $1,500, whether it's paying for, renting equipment or, paying for a building or whatever the case may be. There are fixed costs. And so they can be different, but every year you have to pay the same amount because it's fixed, right? It's set. So if you have 0 products, it makes complete sense that you have negative $1,500. That's what your profit is. You're not making any money because you have 0 products, right? You still have to put out that $1,500. Okay. And then when the number of products is 40, plug it in to your profit function. Don't forget, it's profit. And this one is 6,500. And again, it's profit, so we're looking at money. Okay, and then the other endpoint is 120. Okay, so when you calculate this, when you end up with a negative 25,500. Okay, so like I've always said, in math, your answer should always make sense. You should be able to logically think through, okay, why is my profit negative 25,500 when I have 120 products? So remember, you're looking at profit, right? So just like the last one, your profit is based on how many products you have and how much money you're putting out. So remember before, if we were looking for revenue, we would just do 40 times, the number of products times the price should give me the revenue. But remember, we're looking at profit. So profit is the revenue minus the cost. So that's why the profit is less. Obviously, it's going to be less than what our revenue would be, but it should be the difference between our revenue and our cost. So let's take a look. So we need to find our price, right? It said find the price and the quantity. So we found our quantity. So we know X equals 40. That's the number of bikes. Now we need to find our price. And our price was 600 minus 5 times 40. So 600 minus 200. So our price is 400. Okay, so again, before when we were looking for revenue is the number of products times the price. So that's 16,000. That's our revenue. Our cost is sorry, I just lost my cost. Where'd it go? 1,500 plus 200. There it is. Okay, so our cost was 1,500 plus 200 times 40. So 1,500 plus 8,000 is 9,500. Now, if I take my revenue and I subtract off my costs, there is my 6,500. Okay, so again, you should always be able to double check your work. If you don't trust your work, you should be able to go back and go, okay, how do I find profit? Revenue minus cost. So I find the revenue at 40, I find the cost at 40 products, I subtract the two, and these two numbers should equal each other. If they don't, then you know you did something wrong. Okay, so it asks for the quantity, it asks for the price, okay, and it asks for maximum profit. So if you were to interpret this, it would be maximum profit of $6,500 when selling 40 bikes for 400 each. Okay. All right, any questions on that? Okay, so when you do your when you do your let me get to it. When you do your homework, and this will be the last thing, just remember your part one is going to be the area, revenue, and profit type functions. And I believe there's, let me double check. I believe there's 4 problems, I think, in this one. Let me look. Six problems, sorry, there's 6 problems. So just remember what you're looking for. Always look at it and go, okay, don't let the amount of words throw you. Always look for your main terminology, right? You guys know the terminology and you know what you're supposed to be looking for. So this one, we're looking for maximum revenue. Okay, they give you the price. So remember, revenue equals the number of products times the price. Okay, they give you the price, right? So, and then up here, it always tells you how many parts there are. So make sure you look for the key terms. Maximum revenue, we're looking for maximum revenue. So we're going to go X times exactly like we just did. Okay, there's that kind. And then there was one I wanted to take a look at. Again, maximum revenue. Okay, here is our price. Here's our price right here. And this always throws people, that type of problem. Just look at it. The price is 250 minus 1 over 20 times X. So this X over 20 is just rewritten, just rewrite it as 1 over 20 because it's the exact same thing as saying like 2X, right? You can just use this 1 over 20 as a number. That's a value in front of the X. So that it shouldn't throw you too much. So I wanted to identify that for you because that's always a question. Okay, so we're looking for maximum revenue. And then you're looking for maximum profit, right? So you're going to set up your revenue, which is the number of products times the price. Here's your price. You're going to multiply that by X. And then profit, you're going to take your revenue and you're going to subtract off the cost, just like what we just did. This is exactly like what we just did. Okay. And then, what was the one I was looking for? Okay, so here's fencing. This is exactly like the one with the $2 and $6. Fourth side costs $9 per foot. So I tried to do types of problems that you already have done. So now you're just practicing it on your own. Okay, so make sure that you use the information. And then again, here is your area. It already drew it for you. There's another area, except for this one, now you're looking for minimum perimeter. Okay, so you are minimizing the perimeter this time. So on this one, your objective is perimeter equals 2L plus 2W. That's your objective. Your constraint is you have a restricted amount of area. So area equals 169. Okay, so length times width has to be less than or equal to 169. So that's a little bit different, but now your objective is perimeter, your constraint is the amount of area that you have. So it just flip-flops it a little bit. And then the last one, the last one is exactly like we did at the beginning. You have a perimeter that restricts you, you're looking for maximum area. Okay, so you should do really well on this. Make sure that you are, kind of referring back to your notes. You should be taking notes with this. And I will have the Zoom class uploaded as soon as I can. Sometimes YouTube takes a while to upload, but I will get it uploaded to you as soon as I can. Okay. All right. So any questions, comments? You feel like you got enough information? Okay. All right. So I'm done.
I had a
any-
question.
Oh, sure. Go ahead, Orrin.
So for the constraint, when we found our critical point, so say you wanted to like visualize that better, like how we were doing it before. So you would see that. So you would use 0 from going negative infinity to 40, right? So that would be
Yes.
1.
Yes.
And then since you can only go up to 120, that would be you're going to the right, from 40 to infinity. That would be your max that you can go.
Yes. So it would look something like this. So if you want to see if this truly is your maximum, you could do your test chart, like what we did in first derivative, where you would see it would go up here and down here. But the test chart isn't necessary, because all you're doing is, as soon as you find your critical points, you know that your maximum only happens at the endpoint or at the critical point.
Okay, that was my question. Yeah.
Okay. Yeah. All right. Anything else? Okay. And if you jump right on to your homework, I am in my personal Zoom room from 12:30 to 2:30 today. So if you have questions, please jump in, and I can walk you through any of the problems. I can help you walk through any of the problems in your homework. Okay? All right, guys, I will see you Tuesday. Have a nice long weekend. Enjoy your Easter, and I will see you on Tuesday.
Thank you, ma'am.
All right, thank you.
Oh, nice one. Take care.
Thank you.